Giant covalent structures. Giant covalent structures are similar to the ionic lattice, where there are atoms which are bonded all together via only one type of bonding. Here, the type of bonding is the covalent bonding. This is why they are called giant covalent structures. Example of these are diamond. So diamond is formed only of one type of atom, which is carbon. It formed of a very big lattice of carbon atoms, which each carbon atom is bonded with four covalent bonds to four different carbon atoms. And diamond do not conduct electricity because there are no electrons or no ions which are free to move. So even when they are molten, unlike the giant ionic structure, they will not also conduct electricity. Diamond has a very high melting point. This is because the covalent bond between the carbon atom is a very strong bond and it's very difficult to break. It needs very high energy to break, so they have a very high melting point. The diamond is also very hard because the atoms are held in a very rigid lattice structure, so very hard to break as well. Another example is graphite. Graphite is different from diamond because in graphite is formed of sheets of carbon atoms. Each carbon atom in each sheet has only three bonds with three other carbon atoms. They still have very strong covalent bonds between the atoms in each sheet, and it needs very high energy to break, so they have very high melting points. However, they are formed of sheets, and between the sheet there is a weak bonds between the layers or between the sheets in graphite, and these weak bonds allow the layers to slide past each other. So graphite is soft and slippery. Because in graphite, each carbon atom is only bonded with three other carbon atoms, there are free electrons, and these free electrons are free to move and free to move between the layers as well. So graphite can conduct electricity. So graphite is a giant covalent structure which can conduct electricity. C6 fullerene is not a giant structure. However, it's composed of or is formed of a large covalent molecule. It's formed of a covalent molecule that has 60 carbon atoms linked together. For each carbon atom, it's bonded with three other carbon atoms as well. So there are one free electron from each carbon atom that is free to move. However, the molecules are held together by intermolecular forces and they can slide past each other. So C60 fullerene is soft. The electrons, however, cannot move in between the molecules. They only can move within the same molecule but not in between the molecules, unlike graphite. So fullerene is poor conductor of electricity. So C60 fullerene is not a giant structure. It's just a large covalent molecule.